Cool, the wrong size again. Oh, that's a 1024 by 768. Okay. Awesome. Let's carry all this. Oh,
at the end, we're going to do a question and answer session, but any questions that we don't get answered in the specific time slot that they've allotted for us, we'll just go ahead and take your questions right outside. I'll also be passing out some propaganda, like some. Do you have any mugs left? I don't know if we have any mugs.
I think we just packed some mugs away.
Yeah, I don't think we have any mugs left to give away, but we have some stickers, bumper stickers, things like that.
Maybe sure. All right. I think I'm done screwing around with tech stuff. Okay. So first of all, thank you guys all for showing up. We are Mechanized Propulsion Systems, building the world's first mech. I'm glad you guys all got to show up and check out what we have going on for here. I am Ryan Marlowe, Public Relations and Human Resources for MPS. I've been with the company for going on 6 years now. I actually originally got recruited by being out there like one of you guys watching a panel and going, no way, not seriously, building a giant robot. And a friend of mine actually kind of had the guts to intern before I did and told me, dude, you have to do this. I signed up and I love it. I've been with the company ever since. So, who are we? What are we all about? Mechanized Propulsion Systems Incorporated is dedicated to designing, creating, and piloting the world's first bipedal humanoid anime-style mecha in the next 25 years. We have been around for about 11 years now. We just celebrated our 11th birthday, and we're actually making pretty good progress on that goal. I'm going to go ahead and pick this guy up here. This is our ugly 6:1 scale mock-up of the machine. On the real machine, it's going to wind up being about 20 feet tall. We have several sections of it done already. This torso we had completed. We actually just replaced this with a new version that's a lot smaller and lighter. You guys will actually get to see some photos of it later in the panel. We've got the rotation hub on the machine done that allows it to torso twist back and forth. The engine assembly we are rebuilding right now to be a little bit lighter as well, and we're currently assembling the knee and the ankle structure as well. So who are we? Well, I'll go ahead and introduce the other team members here. Like I said, I'm Ryan. I also brought along Vernon Jetland, our communications engineer, and Christopher Crutchfield, our development coordinator. Some of the other significant people who were not able to be here today. Most obviously, our founder and CEO, Earl Bishop, was unfortunately not able to show up for the con. We have several other core team members, Jeff and Rainika Mackey. We have our, let's see here, various programming staff all over the place, including Josh Tanner. We've got engineers, including Vladimir DeRosa, who is in, let's see here, I want to say Ohio? Yeah. Okay. We have engineers all over the place. A lot of our staff is concentrated in Southern California, since that's where our facility is. We do have people from everywhere. We've had several team members and interns from the Seattle area, actually. And we have engineers all across the Midwest and the South, and we actually have all the way over there on the right, we've got Pete Kozier, our senior staff scientist, who actually does the custom electronics for the machine, and has 30+ years of experience and does some really fantastic work. Between team members and interns, depending on how you count it, we have between 20 and 30 people involved with the company right now. So I'm going to go ahead and actually hand this off to Christopher here. He'll give you a little bit better idea of the place where all the magic happens and how we put them together.
Right. Again, my name is Christopher Crutchfield. I am the development coordinator for Mechanized Propulsion Systems Incorporated. I've been with the company for about 6 to 7 years now. And a long time ago, before we we came to the conclusion that before we could build the world's first mech, we had to design and build the world's first mechanized or mech construction facility, or the MCF. The MCF and its 14 support buildings is located on our 5-acre campus in the Mojave Desert, which is just north of LA in Southern California. This area is home to major players in the aerospace industry. Some names you might be familiar with, like Boeing, Lockheed Martin, Skunk Works, Northrop Grumman, NASA's Dryden Research Center. Also, we have Edwards Air Force Base, and of course the Mojave Spaceport. Now, while our aerospace neighbors are technologically very significant, that wasn't the only reason why we chose this location. The desert also provides an excellent test bed for our prototype because of the harsh environmental conditions, such as heavy and constant winds. We have extreme colds and extreme heats. Hot summers, very cold winters. Now, the MCF is a 4,600 square foot, 3-story building which contains over 200,000 different tools and consumables, as well as a full complement of welding, machining, and fabrication equipment. The MCF also houses the MPS staff offices. We have a kitchen able to brew about 200 cups of coffee, I think, at one single time, which is great for those late partying sessions that we have. As well as we have a conference room that houses, I think it's up to about 500,000 Lego bricks. We're fans of Lego, of course, because we like to build things. And of course, we have a full barracks able to sleep at full capacity, about 15 people. Now, the MCF wouldn't be complete without an internal network which houses helps run our computers as well as our software development. And responsible for that network is our communications engineer, Vernon Jello. Vernon?
Thank you, Chris. My name is Vernon. I'm the communications engineer for Mechanized Propulsion Systems. I hold a Bachelor's of Science in Communications Management. I'm currently working on my MBA, and I've been with the company for 8, 9 years, something like that, and been here for a while. And I moonlight building giant robots, and by day my alter ego works for Cisco Systems in San Jose, the largest provider of networking equipment in the world. So, as the network engineer, or communications engineer, I'm responsible for the flow of information between electronic systems. That's true for both the facility and the giant robot. The giant robot's got a little more complication to it, but if it speaks electronically, I'm responsible for it. Let's see. The mech systems all utilize the 19-inch rack mount form factor. This is fairly standard. It's an industry standard, actually. You can buy almost any kind of hardware that will fit a 19-inch rack. Whatever you need, it can be found. If you can't find it, we can build it. So this allows us to mix and match and swap out hardware, and it's guaranteed to fit in any available slot in the machine. And in fact, with the new cockpit, it's a lot easier to handle that hardware. Originally, it was all in front of the pilot, so you had to pull anything out. You had to remove the pilot's chair. Now it's all in the back, and it's a lot more accessible. But so the systems that we're using are extremely fault tolerant, very high availability. The primary systems are clustered, such as the CMI. The secondaries have failovers, so if something breaks, it's got a backup to pick up the slack. And the protocols that we're using are extremely robust. All the computer setups are using TCP/IP, which is the protocol that runs the internet. You may have heard of it. The sensors use J1708, which is a heavy equipment fly-by-wire protocol used in buses and heavy equipment such as bulldozers and forklifts. So installed hardware in the machine is actually lower than it was last year because we built a new cockpit. But very shortly, we'll be back up to where we were, and we'll be able to move forward a lot better with our setup. We have test fit the hardware, but we're not prepared to permanently install it yet. The cockpit still has a little more work to be done. But, yeah. So, the next thing I'm going to cover is how the systems on the machine work together to solve a problem. And so what happens is we have wind down there. We have wind down there like you have rain up here. So it's kind of a big deal. And it could knock a giant robot over. It's in fact blown the stripes off the road. Here we have a giant robot, rather tall profile, gets hit by a gust of wind. There are sensors, piezoelectric gyroscopes in the upper end of the robot that constantly send information to the computer systems. So the machine is aware of its center of gravity at all times. And so it takes that sensor information and computes it, discovers that its center of gravity is outside of its foot base. So it sends that problem to our miniature supercomputer on board. And it comes up with a couple of different solutions. It picks the best solution that it believes will give it the best chance of success and executes it. The machine then proceeds to right itself and continue on its way. This is fully automated. The pilot has no bearing on it. The machine completely takes care of it all on its own. In addition to being the communications engineer, I'm also the lead fabricator. In fact, I was originally hired to be like a welder fabricator. I just happened to move into networking. As such, I get to build most of the giant robot. And so what we have here is my latest project, the ankles. These are cut and machined last year. I finished the welding a couple weeks ago. They're pretty heavy duty. They were barely carryable as it was, and when I finished them, I can't even carry them anymore, and that's saying something. They're built out of 1-inch plate steel. Yeah. So, yeah. So, in line of fabrication, Christopher Crutchfield is going to give us the status of our new cockpit.
As Ryan I think said, MPS has been around for about 11 years now. In that 11 years, we've made major progress with our research and development. Our original design was using what we call the alpha frame. This makes for a taller and wider torso. It's more like anime style, if you will. We have since retired this design and the development of the MPS Mark I. We are now pursuing the engineering Mark II, using what we call the beta frame. This frame is significantly shorter and lighter than its predecessor, which helped us bring the COG, or center of gravity, down significantly by about 5 or 6 feet. Now, again, this is significant when considering the mathematical complications of balancing such a heavy machine. This frame is less like a Gundam or a Pat Labor and more like something you see at the Battletech universe. This new approach will allow us to fast-track the development of the engineering Mark II. And the sooner we have a proof of concept, the sooner we can prove to the world, and also we can show that there are many industrial applications for this machine. The potential of bipedal machinery is vast, and we believe that there is a full array of industries that could benefit from this technology. Now, to speak more on how we hope to revolutionize these industries is Brian Marler, our PR.
Okay, so the thing that we would normally do for kind of the marketing discussion is display a few animations. We've been having a little bit of dicey issues with that, so I'm going to actually spool those animations after we go through the normal presentation here, so that during the Q&A you guys will get to see all the animations that we've done with some, based on actual research into the various markets that we're interested in selling the machine in. To give you guys the quick overview, the way we want to start out, the initial machine is just going to be a proof of concept. The Mark I, all it will do is walk slowly with a poor turning radius, and if it does that, we will be gloriously happy because that's all it's supposed to do. Basically, yeah, we need to show that this idea will work, and that's what the Mark I is all about, or rather the Mark II now, since we're evolving the design, as Christopher mentioned. The later iterations of the machine, we're going to start out with just fairly simple commercial applications. We don't want to replace necessarily anything in an existing market, but more, I guess, supplement some of the vehicles that are already there. The mech is never going to be an ideal solution for inside a warehouse where all you need is a forklift. Forklift is perfect, it's simple and reliable. As you would get into doing maybe similar types of work though, but under say more difficult terrain conditions, if you're had a building project out in the mountains or something like that, a mech starts to become more and more useful in those situations, and those are the kind of things that we want to market it for. We'll start out with that. As the technology evolves and becomes more mature, and also, quite frankly, we're able to afford more expensive parts, we'll be able to sell the machines for heavier and heavier applications, industrial use. We've actually done a lot of research into all sorts of different disaster response scenarios, which again you guys will get to see in some of the animations. The very long run, we will be interested in doing the military thing, but we don't really want to jump into the guns and rocket launchers yet because the technology really needs to be mature, very well understood, and really, really strong before we're going to even vaguely consider offering it to the military. So that's the short version on the marketing story. I'm going to go ahead and give you guys kind of the last section of the presentation here. How to build giant robots. For starters, it is possible to actually do this just starting in your garage. In fact, that is how we started out. A couple of buddies in high school who just said it would be cool to build a giant robot. We had one guy who, in I think 3 or 4 weeks, flaked out and said he didn't care. The other guy not only stuck with it, he has put hundreds of thousands of dollars into it and turned it into the company that it is today with a significant percentage of an actual working mech done. That, of course, being Earl Bishop, our CEO and founder. But quite honestly, since we've done all of that really difficult groundwork for you guys, the easiest way to build giant robots is to join us and help us build ours. And I'll go ahead and give you guys, I guess, the rundown on how to do that. First of all, who can help? The short story, pretty much anybody. We very often have people who say, this is really cool, I'm really interested in doing this, but I don't know how to help. I don't think I have any skill set that necessarily could, really push a mech forward. That's fine. When I got started doing this, like I think I said before, I had no idea how I was going to fit into the whole project, but I just finally had a friend say, dude, you have to do this. I finally jumped in and did it, and I fell immediately into, what worked best for me. We actually even offer a specific type of position that is just for people who are wanting to kind of try the company out and see what kind of job is best for them. We need people, obviously, in the really concentrated areas of mechanical engineering and computer programming that help put the machine together and move it around. But all sorts of other things, everything down to sewing. If that's what you can do, we need somebody to upholster the cockpit. Seriously. So yeah, even the most random thing. If you're interested in doing this and joining and doing what we do, please come up and talk to one of us. Make sure we get your information and that you get ours, then we can get in touch with you. Why do we want you guys? Basically, skills plus fandom equals giant robots. Yes. Yeah. That is why we show up to this con. That's why Vern and I drove all the way up here from California in my truck. Yeah, with all my stuff.
There you go.
And quite honestly, that formula is what got us started, and it has always what has gotten us the most progress. We have done all sorts of other recruitment events. I've done events for professional organizations, for universities. Out of all of those things, we've always gotten the most people and the best people out of anime cons. Because honestly, when you find people who know what the mech is and understand the concept and understand the kinds of really awesome things you can do with it and have the talent, that's always where we've had our best recruits.
Sweet.
So, for those of you who are current college students, what are some of the benefits of doing an internship within PS? That is how we do the recruitment cycles. You start off with a 4-month internship. It's kind of a tryout period, both for you to see if the company is a good fit for you and for us to kind of, see if you've got what it takes. And at the end of the 4 months, the existing team members hold a vote on each intern. If your vote comes back positive, then at that point you're on the team. Some of the cool things about doing an internship with NPS, you can get course credit for building giant robots. I actually did this. In fact, I kind of double booked it both as internship credit and fieldwork credit, so that worked out nicely. The other thing that's cool is if you start out early with the internship and then become a part of the team, because there's a lot more direct route to doing that here than there is necessarily a lot of other companies, that means that all throughout college, all of the stuff that you do in class, you will have an immediate practical example for. I know a lot, I mean, Vern has done that, I've done that, I think Chris has done that as well. The ability to have people, having some kind of abstract discussion or whatever and always be the person who immediately has the answer because you've seen it in practice, that actually really helps a lot. So for those of you who already kind of moved out of the workforce, why would you want to do the giant robots thing? Because it's awesome, because it's a chance to do something that is outside and beyond what other people really kind of get to do. It's something different and fresh and exciting. Quite honestly, if you're around the water cooler on a Monday talking about what you did in your weekend, some people will be like, oh yeah, I played golf with my buddies, I had a barbecue with my kids, oh yeah, I put the V8 supercharged engine in my giant steel biped. Yeah, it's kind of a conversation stopper, or conversation starter if you have cool coworkers. So. So, what's the easiest way to get from being out there to being up here? The number one way is to come talk to us after the panel, make sure that we get your info and that we can get in touch with you. The number two way right after that is our website. If you go to mechaps.com/jobs, that will take you straight to an online application. You can fill that out, submit it, and it will immediately appear in front of our HR staff. So that wraps up the prepared portion of the presentation. I'm going to go ahead and actually open us up to Q&A. We've got the contact information up there. I guess I'll go ahead and leave that there for just a moment, and then I will pull up some of those marketing animations and spool those for you guys. Pretty much just raise your hands, and we will haphazardly point at random people and answer your questions.
Power source.
Gasoline internal combustion engine.
Okay.
Yeah.
That's the initial specification for the first prototype.
Yeah. Technically, anything that turns though counts.
What
Yeah.
kind of operational lifespan does it get?
Kind of depends upon what engine block we use and how hard we push it. We're using a Chevy 454 big block V8 racing engine, and there's a lot of things you can do to get a lot of power out of that. I think we're just going to start out supercharging it, so it should be okay. But if we end up breaking it, we'll have to go up to something a little more durable. It depends. Lime green shirt.
You said this counts as field credit and internship credit towards colleges. Is that
Depends on your college, but yeah.
Is that just like Caltech or something inside California?
I considered one from Oregon.
Oh, very good.
I got internship credit. A lot of the co-op programs don't expect you to have your internship necessarily close by. And so if you talk to your instructors, you can use them to work on something further away. Some schools will even do over campus. So doing something not where you live is not unusual at all.
Well, I wasn't in California. The university I was going to was like 5-6 hours away from the NCF, so yeah, the physical distance is not a big deal. Yeah. Okay. Orange shirt.
Enter booth at the
Exhibit hall. Yeah.
exhibit hall, and I saw it in one of the animations of the hydrogen fuel cell as a power source. I'm just wondering, are you guys working with car companies that are developing that as well, or are you working on that for yourself, or just hoping someone else will develop it and that?
Well, we're not necessarily partnering with any other companies developing anything like that right now. It would probably be something that if we get to the point where we can get the, I guess, power to weight for the engine and the also, I guess, power concentration to wait for the fuel out of doing a fuel cell, we can do that. The machine is kind of designed to be modular, so whatever technology we can slot in there, we will. We do want to push the machine towards being more green than it is now. As cool as it is to have the big beefy racing engine and everything, we are really all about the environmentally friendly thing. It kind of sucks that we don't really have a power source that can do what we need to do that is more green, but we definitely want to move towards that in the future. Yeah.
To expand on that a little bit, the hydrogen fuel cells is specifically for spaceborne applications. Like if we wanted to send one of these to Mars, you'd have a factory that you can put water into, break it down to hydrogen, and compress it, and then use the hydrogen to run the machine, which is useful for something like that. But yeah, anything that turns with enough power to get it to go is a viable engine alternative.
What kind of user interface are you looking at doing this? Like, I played Sakura-Con on the Xbox and everything, and that was nigh on impossible.
Yeah. So
Yes, it is. I own it.
Yeah. In fact, we were considering at one point taking pictures of the Steel Battalion controller in the cockpit with him sitting in it. But the user interface is actually really interesting because there is so much going on in the machine. No human being can be realistically expected to keep track of all of it. The decision making with the machine being hit by a gust of wind and whatnot, it has the artificial intelligence system, which unfortunately we don't have any of our experts on that here. Otherwise we might have covered it. But there's a very complex artificial intelligence system that actually runs the machine. And so the pilot actually runs the artificial intelligence. He gives executive level commands to the AI, and the AI executes it on the machine. And so the interface that you use for that is kind of up to the pilot. And so your preferences and things are stored on a pilot data pattern, which is the USB key, and that governs how your interaction with the machine happens. And so whatever you want to use, you could control the machine with an Xbox controller or a Steel Battalion controller, or a steering wheel with a big red button. So it's really abstracted away from gear shift and steering wheel. But we'll probably end up using mostly a joystick and throttle.
Yeah, sure. Yeah.
It's funny you mentioned Battletech because I just spent 5 hours playing the Battletech campaign.
There you go.
Yeah. Sure. Died.
Yeah.
Yeah. It happens.
That'll do it.
Yeah. Actually, I have several questions because I've got to agree with the Max in the Battletech universe.
Okay.
Now you said
Hopefully we'll trade back and forth, but either way.
Yeah, you said the sensors for the gyros were in the shoulders.
The upper portion of the robot.
Yeah. Now, do you actually have a centrifugal gyro in the center torso?
No. There's no physical gyro.
All right.
Yeah.
So how do you pick the balance? And is it just manipulating the legs?
Yeah.
Or?
Manipulating the legs, manipulating limbs, turning the torso because the front and the back will be slightly different weights. So you can shift the weight. So the machine has a number of different actions you can perform to shift weight. as well as
So you're
being
not
able-
actually using a central gyro, you're
no,
trying to shift
no,
it.
it's active balancing like a human would do.
Yeah.
Well, other thing too, now hydraulics are prone to slow movement,
Yes.
obviously.
Yes.
And what it looks like here, you're using a regular bipedal mount chicken walker
Right.
with a hydraulic system.
It's actually not hydraulic.
It
Well,
is not hydraulic, it is-
the main forward motion is direct drive off of the engine. It just has a custom transmission set up that outputs to a scissor mechanism that drives the legs forward. It's a real simple thing. You can build it out of Legos.
Yeah, and I
Yeah.
understand for power output, the simplest is gasoline right now.
Yeah.
Because it gives you the most power for the cheapest return. And weight, of course, is the major thing. If you've done BattleTech, you have
Well,
weight ratio,
oh, yeah.
space ratio, and all that.
Weight and heat and everything. Yeah.
Heat generation.
Right.
Are you guys familiar with the, I believe it's John Deere that makes the six-leg?
Yeah. Timberjack.
Yeah.
Yeah. Yeah. We've done a little bit of looking into that. Yep.
Yeah. Another thing I was looking at for your thing, you're saying you're using a mechanical system. Have you guys looked into the retractable fiber musculature
Yes.
idea?
Yeah, we've actually done a little bit of looking into that. In fact, if you want to go with the BattleTech angle on it with the myomer fibers, the
Yeah, I
metal
know the
muscles.
technology exists and it's in its infancy, but
You know what? To be completely honest with you guys, we actually have a tech demo that we sometimes drag to cons. We don't have it here, where we actually have that. We have nitinol wires that you can apply a current to, and it will move a little metal bar up and down. It's a really simple demo, but we do actually have that. You just click a little button and it moves back and forth. It's really cool to
obviously
watch.
that's future down the road.
Yeah, it is down the road. There's a lot of heat and I guess electrical interference issues to manage with that, but we definitely do want to look into that.
Yeah, because it takes out the mechanical moving part.
Yeah.
Bounce back and forth here. Sure.
Okay.
Yeah.
For the different interfaces that you guys
Mhm.
run, has anybody looked into using something similar to the Epoch helmet?
Epoch helmet. I
Is
think
that
we're
with
going to Epoch helmet.
the eye tracking or
That's the actual marine helmet.
Okay, yeah. So OCZ makes like computer components. They have what's called the NIA input device. It's like neural input actuator or something.
Yeah.
I have one. I can't use it. It's hard.
Yeah.
But yeah, we have been looking into that kind of stuff.
Yeah.
Again, back into the BattleTech thing, neural helmets.
Neural helmets.
Yeah.
Yeah.
But again, the interface is abstracted, so you can use any kind of input device. But we are looking at that as an option.
Yeah, it would be a little ways down the road. We want to stick with what's kind of proven and reliable for the foreseeable future. But yeah, to be completely honest with you, I have definitely checked out the videos and stuff for that. So that's a possible down the road option for it.
It takes a lot of training to make it work.
Yeah.
Pilot feedback. Hey.
Okay, I remember some weeks ago, I think it was on 60 Minutes, something about something, I think it's called a bloom box.
Boombox. Oh, I heard about that. I didn't get to read about it. I actually bookmarked a couple articles on it and I haven't read them yet. Okay, go ahead.
Are you looking into it then?
Well, I will be, I guess. In terms of
it's-
power source, it's a electrical generation system, right?
Yeah, I believe so.
Yeah. Okay.
So it
I-
might be worth some looking into as
It might
as
be
an
a power source that
alternative.
we could look into. I'm pretty sure it's something that's big and heavy and meant to be an emplacement device bolted into the floor in a building somewhere. But like I said, I still
think
need to
they can
kind
be
of do the
different
research into that.
sizes, so-
Hmm?
I think they can be different
Different sizes, right? Yeah.
So
I
you
might
might
want
want
to
to
look
see if
into
you
that.
can
I
use
don't
it
remember
in
to do
place
that.
of an internal combustion engine. It
Usually-
would still, I believe they still use fuels like an internal combustion engine does, but it's a lot cleaner.
Perhaps for auxiliary items, things that don't actually do the direct drive to the legs, because there is a lot of other systems. There are a lot of other systems on the machine that have to be. They do have to have their own
Electrical
independent
power.
electrical power. We have all of the computers on board, a lot of the pneumatics, hydraulics, things like that. Those all have to have their own power source that is semi-independent or completely independent from the main drive.
Yeah. If I could just remember what it was called, I'm pretty sure it was called a bloom box.
Bloom box,
That
yeah.
sounds-
Yeah,
I
that is.
think
I've heard of it.
actually, It's just a technology.
Back there.
All right, watching your guys' demonstrations, I see you guys have a lot of off-road stuff. With the weight of the mech, how are you guys gonna combat it sinking in?
Okay, so the ground compression on the machine is actually really low. The machine will weigh between 3 and 4 tons. With a new cockpit, it cuts down the weight substantially. But the foot placement, the footprint, I guess, is significantly larger than comparable vehicles. Like the footprint of your car on the ground is actually like a square foot. The actual tire contact is very low. And so the amount of ground compression generated by the feet is actually less than that of a normal vehicle.
More like a tank then, huh?
Yeah, yeah, it's intended to really spread out the weight a lot. In fact, we had a fairly large foot. I believe the statistic was a size 123.5 shoe. But we actually just are redesigning it now to be even bigger to help spread out the weight.
So it works in here. I had a question about the actual user interface, and I was wondering if you had played with the idea. I don't know what this technology is called, but the technology of putting on basically
Motion capture?
motion capture, where you actually put on a glove that captures your motion, and the arm mimics what you does.
It's just a relay
Yeah.
system.
Yeah.
Right, and I was
We've
wondering,
actually-
yeah.
because if you get that to work, it seems like it would be the most simplest way to control it.
To a certain degree, that technology is still in its infancy in our analysis. We actually used to do a demonstration with what was called a P5 glove, and that actually was a 5-point plus yaw, pitch, and roll. It had sensors and all that, and it actually read, I think it was an infrared sensor read to a control mechanism that read the actual nodes on the glove. We used to do a demonstration with that because it is a viable technology, we believe. Maybe not right now, but definitely in the future. Again, with the abstracted layer for the PCI, or the pilot control interface, it's up to the pilot completely. And also, we'll be able to adapt with any emerging technologies that are exciting and possibly viable.
And there are much higher quality systems like the it's like a Waldo system from an
Yeah.
ILM. It's very nice.
Yeah.
So, there's plenty of scenes with the mech lifting. What kind of extension would it have without any, like, major adaptations, like just the forearm, shoulder extension, and how much it could hold at that distance?
The arms are not really spec'd yet. Robotic arms have been built since like the 1950s, so we're not really focusing on the arms right now. We'll probably end up contracting out for robotic arms to somebody who builds them, because we don't really want arms, we want legs. But so it's dependent upon the model of the arm, and what you plan to do with the arm, and how the machine is outfitted. Because again, it's all completely modular. So if you need a longer arm with more lifting capacity, you can do that.
It's not just the amount of weight the arm can manipulate around. It is you pick up a bunch of weight, the center of gravity suddenly shifts.
Yeah.
Right. Yeah.
Right? At the current stage, how much could it lift at, say, 5 feet from the cockpit up to cockpit height?
Well, at the current stage, it doesn't have any arms.
Yeah.
But the Mark II.
How much gibbets?
Yeah,
is
the
that?
Mark II, we're planning on probably moving boxes probably around 300 pounds or so. And if it does that, we're happy. That's what the Mark II is supposed to be for, is to demonstrate that the complete system works. It doesn't have to even do it very well, as long as the whole thing works as a package. The Mark III will be a lot, like this is concept art of the Mark III. Will be the first production ready machine. So we don't really have any numbers on that.
Yeah, the arm thing is a little bit further out there, but yeah, it obviously is something that we will evolve into as the technology develops.
As you mentioned, the COG, the center of gravity, does shift. Much like a human would shift its center of gravity if it's picking something up. It doesn't. You don't just stand there and go like that. You actually shift yourself back and balance
So it is
yourself
designed
out.
to
So
compensate that.
it is
Right, to
designed
actively
compensate,
balance itself.
To
Yeah,
actively
absolutely.
balance without actual pilot control. Any input
Yeah.
actually. The machine should counterbalance itself intuitively.
I love the modular.
You keep mentioning the counterbalance, but the functioning of the legs is all geared. As you said, it was all done by
Right, direct drive.
assembly.
Yeah.
How exactly would it be able to move one of the legs independently to change that center of gravity?
Clutches in
Yeah.
the planetary gear system.
Yeah, two independent clutches basically are you clutch each leg separately. Each would sort of, I guess, have its own, I don't want to say its own transmission, but its own separate clutch.
Yeah.
Pretty much.
one separate gear system.
The Mark III will actually have two separate engines, so you can
Yeah,
rev
that's
one
true.
independently of the other, and so you don't have the clutching system. They're independently powered.
For smaller adjustments to weight positioning and whatnot, we have actuation in the foot, in the ankle, in the knees, and in the where it connects at the hips with big hydraulic actuators. So there is a bit of pivoting that can happen there to right the robot, right in the right center of gravity.
Back.
In regards to your control system, are you planning using a control by wire or are you using a digital means of controlling the machine? And if you are using digital, would you be using a base form of feedback, let's say springs or hydraulics?
Feedback in what way?
Say for instance, like you're flying an aircraft. Most aircraft are fly by automation. Oh, they're digital now.
Yeah.
Fly by wire.
Oh, I see, like feedback in the joystick or
Now,
something.
if you have digital feed, you have no feedback, you can easily override the aircraft because you just pull back, you feel nothing, and
Yeah.
crap, you're screwed, versus, hey, I'm feeling resistance, I just want to stop pulling.
Yeah. That's dependent on, I guess, the model of joystick we use. We can incorporate force feedback in the joysticks. And that's, like most gaming joysticks. I mean, the joystick we have spec is actually a really nice gaming joystick. And so, having that capability is definitely
there. Yeah, and it's all digital at this point. It's not. I mean, nothing is like a physical by wire motion. We may at the very outset have actual I want to say manual shifting for the engine on the current Mark, but we're really trying to get away from that. It's not really ideal for what we're doing, and we're probably going to design around it and not have that. So everything will be digital and abstracted through the pilot control interface.
Yeah.
Yeah.
How much is all of this going to cost? Like, how much do you think the actual production, is it cost effective?
Okay. The project to date has cost somewhere in the vicinity of $1 million, which isn't that bad for a company running for like 11 years. But
Only 1 million?
Yeah. We run pretty lean. That's why it's taken us 11 years to get to where we are. But there's a trade-off. The production machine, the Mark III, it should cost about $1 million for the machine, the MTB transport trailer, a set of tools, pilot training, and service warranty, and software lease.
Yeah, the full package deal.
You guys probably talked about this already, but I just walked in,
Don't
so
worry
I
about it.
didn't hear nothing about it. Military applications?
Oh, okay. Military stuff. I guess I'll do my quick spiel on that. We're going to start out marketing the machine in commercial and industrial uses. We don't want to jump into the military thing because we'll need to really evolve the technology a lot, make sure it's really mature, safe, well understood before we ever suggest putting it in a combat zone at all. When we finally go to do that at some far point in the future, we definitely don't intend for the mech to replace any other vehicle that's out there right now. A lot of people will walk up to us out of the blue and just say the mech will never replace the tank. We don't want it to. That's kind of a ludicrous assertion. The tank will always be the best tank. It's heavy, extremely well armored, and carries some extremely powerful weaponry. The mech would be more comparable to a walking, a land-based, I guess, function of what you would get out of maybe a helicopter, maybe an assault helicopter, depending on how it's set up. Something that is intended to be lighter and more maneuverable, something that can access really inclement terrain and get to places that other vehicles could not, and that would be more the advantage of it versus it just being tough and able to take shots directly to the torso. We're not really wanting to do something like that. Quite honestly, the mech is probably not ever going to be at least not in the foreseeable future, any kind of really direct frontline combatant, something that you would, storm the gates with. It's more something that would be used as a, I guess I would say a support vehicle, or as something that can be used at longer ranges, or for scouting purposes. It would not be something to, again, be charging a, tank battalion with.
So more along the lines of, say, an urban assault support unit that can be right down there on the ground, but have the mobility of infantry, but the firepower of like an infantry fighting vehicle.
Yeah, yeah.
And which leads up to my question: what is the speed that you have it at right now, ground speed? Like, if you wanted to just move it as fast as you could, how fast can it move?
Well,
We've jumped around a lot in those numbers because we've gone through so many different designs within the last 11 years.
Yeah.
I think the rough math, and don't quote me on this, but I believe the rough math on the original design many years ago was something like 160 miles an hour. Which, no, not really possible.
that was just the aerodynamic.
That was just the aerodynamic calculations. There's a lot of mechanical limitations that come into something like that, of course. But I don't know. Our current prototype, I think, what did we say?
Yeah.
5
yeah.
miles per hour?
The current one, if it walks at 5 miles an hour, we'll be totally happy with that. Later versions of the machine, it'll probably only ever be safe to take it, maybe 35, something like that. Quite honestly, the engines will be able to output more than that, but you run into an issue where the way that the machine is able to kind of remain safe and remain balanced is that it has a whole lot of systems that make it aware of its environment and what's around it, of the ground compression, of what it's stepping on, and all sorts of stuff like that. And it compounds all of that information to, I guess, constantly calculate what is the best and the safest thing to do, best place to place your feet, stuff like that. The ability of those systems to react, the ability of the cameras to pull in and process imagery at any speed over, say, 35 would be really dicey. So it's become something where even if the engine is able to push the machine faster than that, the rest of the systems aren't necessarily going to be quick enough to react to that.
So it's something that might actually, the upper limit for that will possibly go up as the software and the hardware
Potentially, yeah. I mean,
evolve to
obviously,
match
yeah,
it.
as the tech evolves, yeah, it can get faster.
Okay.
So the faster it goes, the dumber it gets.
Yeah.
Well, just to give these guys an idea of real-world application, the M1 Abrams has a governor on it to keep it from going over a certain speed,
Yeah.
because the engine will allow the tank to go over 60 miles an hour, but to do so will destroy the drivetrain of the tank.
There you go,
For the
yeah.
road vehicle.
I've seen
And
somebody.
so they keep it from doing that. In addition to military applications, the main bonus that a mech has over a tank is that it is one guy instead of a crew. The tank requires a crew of 3, so you have less manpower, and it also has the ability for multi-terrain where a tank could not go.
Yeah.
And that's the big selling point of the mech over a tank.
Abrams
If you
has
give one guy the firepower effectively of an armored vehicle by
Yeah.
himself.
Right. Yeah.
Yeah.
All right. Go back here, I guess. Yeah. Yeah, go ahead.
So, I'm not sure if you've already considered it, but top speed could really be dependent on the design, obviously later stage. But if something is designed for urban travel, you can have it designed to operate on asphalt and concrete, and knowing that's the only surface that it's designed to operate on, you can remove some of the limits or default some of its programs so that it's not necessarily sensing, can this hold my weight?
The machine will
That
actually
would
be aware
still
of
depend-
what it's walking on.
That would still depend on
Yeah.
things like
Anyhow,
pieces of building that fell on the ground,
Absolutely.
or
So,
potholes, or
to a certain degree, we will be building in
the-
some kind of pressure sensor into the bottom of the plate.
the machine between its visual input and the sensors in the feet, it'll be able to determine more or less what it's walking on and be able to react accordingly. But the physical limitations are the mechanical limitations of the legs. Again, the ankles will be heavy. Later models will, of course, have everything lightened up aluminum and composites, but as it stands now, the swinging those things around is going to be a huge chore. But it'll really be limited by the software.
Okay. Real quick, we should probably just do about maybe 2 more questions. We need to probably wrap up and get our stuff out of here so we can, people for the next panel can set up. We will definitely be just outside the room, and we'll still be for a little while at our booth number 627 in the exhibitors hall, all packing up. So if you guys after that want to follow on and talk to us some more, you can definitely do that. So I'll do in the back green shirt.
In Medic and Onward, there are panoramic cockpits, so you can literally see it in all angles. Are you guys developing anything like that? type of thing?
Not right now. That may be something for later. The current cockpit has pretty good visibility. It has kind of a, sort of glass section that comes down. I almost want to say kind of X-wing-like with just sort of a frame, but a lot of glass around it that lets you see through. The ability to see other areas around the machine would just be assisted by cameras and LCD screens. Yeah. I'll go over here.
Usually, in commercial applications, you're still looking into pilot training programs. So,
Mhm.
like, we develop a pilot training program that's starting that you have. What qualifications you're looking for? Say, experience with heavy industrial machinery or certain materials, such as
Yeah, definitely. Those are actually a couple of the strong points, especially experience with heavy machinery. Quite honestly, the test pilot position is the most applied for and the most flunked out of position in MPS. In fact, if you want to do test pilot dev stuff and you start out with an internship, you will do no test pilot stuff during your internship because basically during that time you get whatever sort of odd jobs to basically prove that you can hack it and that you have the dedication to stick with it. Because we get a lot of people who just sign up because robots are cool to do the test pilot thing and have no real ability to do the work. That said, through that, the current test pilot program is really more designed around helping finish the layout, both physically and of the menu systems for the machine. In terms of later on actually selling the machine, test pilot development, that's something that we intend to do both with a simulator training program and then obviously with actual hours in the machine.
So aviation psychologists and physiologists will help out in this.
Certainly, yeah, absolutely. Yeah. Okay, I think we'll probably have to go ahead and button up our stuff. Like I said, feel free to follow us outside or back along to our booth for some more dialogue. And make sure if you guys are interested in joining up, come up here right now and make sure we get your information.
Congratulations on holding construction.
Yeah.
Hey, no shame in that.
Hey, it's got somewhere. No, construction. Before treads were used for testing.
We'll have to move quick, so I should probably.
They're gonna get on us as we practice.
It's going to wind up being probably about 20 feet tall. Keep talking. Yeah, name, email, and focus.
Applications sharp enough.
The last name is.
Sorry, I'm walking. Oh, I just want to get into the video show.
It's Waldo! I found Waldo! Haha!
Oh, Howard beat you.
Ah! I found Waldo! Yay!
Leveraged Advanced Parity panel. Yeah. The guy